So we are studying this unit number 4 related to the basic instrumentation on the behalf of research point of view, or on the nature of research point of view. And as a student, we are the researcher, and from our point of view, we are going to learn the things. So many more things we have seen. As I told you, the while completion of the things, we'll have to do the market survey, questionnaire, self checklist, personality inventories. So any raw things are there that will have to converted into the finished product. So your achievements, your project devices, sociometric approach, that should be there. Then we have seen the general criteria of the good instrument. Of course, the instrument should have validate. If it is not validate, we'll have to make the calibration and we'll have to decide it is validate or not. Then reliability, that ability, whatever the readings are there that are okay or not, that will be the reliable instrument. And readability, so many more instruments are not properly readable. So in that case, the worker, as per his experience, he can define or he can judge the outcome. So it is not like that. There should be the readability, there should be the proof for that. So many more examples also I have given you. So for validity, we have learned about the things. Then we have seen these are the types. Then reliability examples also I have given you in case of the reliability. So after that, we reach up to this point, that is measurement system. In case of the measurement system, I told you there are the basic two types of the measurement, as like static characteristic and dynamic characteristic. These are the two major important measurement system. So as I told you, the static parameters are, static means the set of the criteria which can be defined by the instrument for measuring the quantity which are slowly varying, or the parameters or readings which are slowly varying with respect to time. So that we have seen under that criteria, we have seen the accuracy, sensitivity, reproducibility, drift, static error, dead zone, precision, threshold, and linearity. For that, one by one, we have discussed the things as like uh, this will be the accuracy and precision. So in case of the accuracy, I told you accuracy is nothing but it is a degree of closeness for a particular value, specific value. And in case of the precision, I told you the closeness which can be measured by comparing other results. That will be the precision. Correct. So I have explained this example: high accuracy, high precision, low accuracy, low precision. On the basis of this diagram, I have explained the things. You have drawn these things and written the things. Then linearity, I told you, linearity is nothing but it is the ability which can be produced, the output as per the input parameter. If the output with respect to input is directly proportional, it means the nature of the outcome is constant throughout the input. So that should get the linear curve. You can see the dotted parameter. This will be the linear. So why linear? So it is directly proportional. So that nature is linear. So I can define, or I can say E is equal to mc square. In that case, the mass is directly proportional to always E. So that will be the linearity equation. So here equation is y is equal to mx. So this will be the condition is given. Then when non-linear, we can say at the time of input, proper variation will occur every time with respect to output. In that case, we'll say that curve is non-linear. So what is the role of linearity and non-linearity here? As a researcher, while designing the things or while researching the research while doing the project, in that case we'll have to know the nature of the parameter. Either it may be linear or non-linear. If linear is there, the procedure is different, and if non-linear is there, we'll have to follow the multiple parameters. So likewise, we'll have to consider the linearity and non-linearity. Correct. After that, dead zone is very important. I think we have reached up to this point. So dead zone is nothing but it is the range which can be measured and which does not, which have not given any response at initial stage. That we called as a dead zone. At initial stage, it will not give the response. You can see the figure. See, first graph, measured variable. While starting from y-axis, at initial position, it will not directly jump, or it will not changes in the output, correct? So slowly it can be changed. So the initial stage is called as a dead time or dead zone. Here also second graph, it is a constant in nature at the initial stage, and after that it will take a rise in the graph. So initially it is very less rise, and after that it will increase the output or y-axis reading suddenly or tremendously. So because of that, the initial position where instrument does not respond, that we called as a dead zone. Correct? Example: while standing on a weight machine, what will happen if weight machine is digital? In that case, it takes the time. What time? 0.00. It will take a time, and then it will set, and then it will show the reading. So the initial phase of that machine is called as a dead zone. Correct? So this will be the dead zone. I hope you understood this. Is that clear? Dead zone.
Yes, sir.
Okay. Baki J, Sagar, are you getting it? Sampath.
Yes, sir.
Okay. Okay. So just write down this and draw the graph from your end. Just write down in your own words, and the graph is important, and you can quote any example. Dead zone. Okay, just write down the things. Dead zone. It is the largest range of the values of a measured variable to which the instrument does not respond. That is initial stage, at initial stage. The dead zone occurs more often due to static friction in indicating an instrument. Correct. A practical example, they have given the example: due to static friction, a control valve does not open even for large opening signal. Correct. From the controller. So that will be the sensing device. It takes the time, and after realize the things, after setting the things, then it will work. So that we called as a dead zone. Therefore I have quoted here one graph: measured variable with respect to instrument reading. So in the two graph there is a dead zone will occur at initial phase, and then system will start to run. That will be the dead zone. After completion of this, just tell me, after reading written the things and drawn the graph. Of course, on x-axis, y-axis, you will have to write x-axis input, y-axis output. Likewise. Okay, Yogesh is there. Yogesh, are you getting it? Okay, okay.
Yeah.
Yogesh, your voice is not clear.
Sir, I'm with
No, no, no. Your voice is not audible. You can just message. There is a option. You can text message.
yeah.
Yes. So that I can read.
you
Okay.
able to listen me?
Yeah, no, your voice is not audible, Yogesh. Okay, you can just message. We'll move forward. I think you have written the things and drawn the graph, correct? Shall we move?
Yes.
Yes, sir.
Okay. Pranav is also there, no problem. Okay. So this will be about dead zone. This is again same, that it is the largest change of the input quantity which there is no output, or at the initial stage there will be the no response coming from the instrument side, that we called as a dead zone. So as we have seen in the previous slide, same, this we called as a dead zone, straight line, no effect. So it will be the null effect, and after that it will start the output or input. So no need to draw this. You have drawn the previous things, no issue. Then static error. Static error is nothing but the error which can be difference, which can be create a difference in between true value and calculated value by the experimental setup. So that we called as a static error, because at the time of the instrument using, we must aware about the static errors, that is the true value deviation in between true value as well as a measured value, that we called as a static error. So here also I have mentioned some points related to, I think, static errors. We'll see, but here important is we must know what is static error. Static error is nothing but it is the difference in between true value, defined value with respect to measured value. Many times what happen while using the instrument, or while handling the instrument, there might be chances of the difference create, because as per the standard the instrument conditions have given, these are the outcome, but after long time or after long cycle or after using lot many times, that deviation will occur. So that we called as a static error. If the instrument we are using such kind of the error, so it will not fulfill our purpose, or it will not give the proper outcome. So that's why we need to avoid the static error, and that static error, it comes under the category which we have seen, the static characteristics, correct? So right now we are here, we are seeing this static characteristics, correct? So this is about the static error. So just write down second, or whatever be the point number, you can write the is static error is the deviation. Just write down that static error is the deviation Okay, have you written this? Prashant? Hello.
Yes, sir, done, sir.
So now hysteresis. So this is not included here. मी इथे include केलं नाही static error मध्ये. But hysteresis, these kind of the losses will occur. So that we need to find out. So what is hysteresis? Hysteresis means it is the gap while finding the input is different and output is different, and same condition we are implementing or we are applying more load in that case, and whatever be the outcome is got, that will be the difference, gap difference, initial and final stage difference we can see. So that we called as a hysteresis loss. And hysteresis, they have written, see the graph, input and output. So around 50% hysteresis losses are there while comparing the input with respect to output. Likewise, now see the hysteresis is nothing but it can be the different output effect as case of the initial and final. So here they have mentioned the loading and unloading condition. Correct. So that will be the called as a hysteresis losses, and many times it will occur because at the initial stage, of course, the conditions and parameters are different, and at the final stage, conditions and parameters are different. It means while developing the product, we are just having the prototype modeling. Suppose we are doing the prototype modeling. In that case, we have considered the parameters, how to develop that prototype modeling accordingly, and that parameter, and after prototype development the testing has been done, and after testing while developing actually that product, so then there the parameters are changed or scale can be changed. So that difference is called as a hysteresis. And of course this kind of the error will occur everywhere, no issue, but we have to consider by the graph, because the plot shows it will not deviate more, it will not create a more difference. If it is so, there will be the problem. Correct? Have you understood this hysteresis?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Just write down, I'll tell you. Hysteresis is nothing but hysteresis is nothing but the phenomena which which illustrate which illustrate the different output effect at the time of loading and unloading. At the time of loading and unloading. Correct? So you can draw the graph, and if you are interested, you can write the things as like they have mentioned. For increasing the value of input, an instrument may indicate one set of the output value. For the decreasing value of input, the same instrument may indicate it different set of output value. Correct? When output value are plotted against input, following kind of the graph is obtained. So it is just like an example. Just write down the things. झालं की सांगा मला.
Done, sir.
Okay. Now this is about the hysteresis. Of course, input by output graph. Next will be the static characteristic. Drift. Drift is nothing but unsudden or unexpected change, that we called as a drift. As an example, I have quoted one diagram or one graph, one photo. So that will be the unexpected things will occur because of the situation. So that we called as a undesirable change, that is a drift. Now drifts are having many more types. So zero drifts are there, or we'll see the types. Drifts are there. What it indicates, drifts is nothing but undesirable thing which will not give the proper outcome. That is drift. So this kind of the things are occur at the time of research. How? Suppose I am taking a reading, and many times it will occur that the instrument is have lost their property, and we are just thinking that the instrument is okay, and we have collecting the readings, and that readings are not matches with the previous or base readings. There are many times that happen. The readings have been taken by the researcher and put it and directly public for use for the publishing, and then comments will come that it is not possible such kind of reading, give the explanation and all that. In that case, our time of the publication is again increased. The comment will have to reply, and again we will have to take a rereading, and then we'll have to finalize, then we'll come to know that it's wrong. Then again reprocess, rework will have to do, and then we are going for the publication or defining the things. So that is the undesirable effect of the output. We have decided that we have do the project, we have calculated the reading, we have published the reading, and systematically it will go on. But it is not like that. It is a time consuming process. And if your instruments are not proper, then that portion we call it as a drift. Why? See, I'll put one example from my side. In 2017, I have published one paper, research paper, in Springer journal. And the Springer is one of the standard most journal. Uh, so in the month of May 2017, I have just sent the paper. They have given me the acceptance after 10 days. And after acceptance, they have taken minimum 8 to 9 months for the reply. And in 2018, I got the reply that these are the drawbacks, these are the loopholes, and you just give the reason behind that and resend us paper. So in that time, at the time of publishing 2017, I thought within 1 year my paper will complete, but it is not like that. The comment after 1 year I have submitted, and then in 2019 I got comment that your paper is rejected. So it means the 2 years I have spent in that particular purpose. So that is drift, correct? So such kind of the drift will occur in our day-to-day life in many more example point of view, correct? So this is about the drift. So I'll tell you the types of the drift. So you can see the type of the drift from the graph. Zero drift. Zero drift, in that the deviation will be occur with respect to initial to final decision, that we called as a zero drift. So correct. Then second, span drift, whichever I told you, that will be the lengthy process. Span drift. Zonal drift. Zonal drift means in between the process the problem is stuck, no outcome, no inputs are given from the researcher side as well as publisher side. So that will be the zonal drift. In between the process is stuck. Example again, many more things. While doing the metro, or while building the structure, while building the flats and all that apartments, there might be chances many more buildings are right now, since last 3 to 4 years they are standing still, they have not completed because sanctioning problem, the space is not work, um, the availability of sources is not there, the proper documentation is not there. So these kind of the things are there. It comes under zonal drift. So I hope you understood. Are you getting this?
Yes, sir.
Okay. So just write down definition. Drift, it is an undesirable change, undesirable change in the output, undesirable change in the output, correct? Or in addition to that you can write, see स्लाइड मध्ये मी बऱ्याच गोष्टी मेन्शन केलेल्या आहेत बरं का. रिझन हे आहे की जेव्हा तुम्हाला मी हे पीडीएफ पाठवते, तुम्हाला अभ्यास करताना बुकची गरज पडणार नाही. या पॉइंट ऑफ व्ह्यू मी हे जे काही वर्डिंग्स आहेत ते मी टाकलेले आहेत, त्याचा पर्पज तो आहे. that is as like a short notes, so you can refer for this. So त्यामुळे प्रत्येक वेळी मी काही रीड करून दाखवू शकत नाही किंवा दाखवत नाहीये. I'll just tell you the crux, what is the concept behind that, and according to that you can, while reading the things at the time of study, you will get the idea. These are the things. So you can write the drift, and we have written this. A drift may be caused by environmental factors. Write down. It can be caused by environmental factors like mechanical vibrations, comma, changes in temperature, comma, stray electric field, comma, magnetic field, thermal EMF. So this is related to instrument. कारण आपलं चॅप्टरचं नाव इन्स्ट्रुमेंटच्या रिलेटेड आहे, म्हणून इन्स्ट्रुमेंटच्या रिलेटेडच दिले. व्हायब्रेशन असेल, चेंज इन टेम्परेचर असेल, इलेक्ट्रिक सर्किट असेल, थर्मल इफेक्ट असेल. So that will be the factors for drift. Again, you can write the point. A drift in the calibration of instrument occurs due to aging of the component part. Of course, aging is done, because of that drift is occur. And in case of the flow measurement, due to wear and tear primary sensing elements such as orifice plates. This is an example. So you can write this with respect to orifice plate example also, or else you can write the general example as I told you. Then they have mentioned the drift occurs in the temperature measurement due to scaled formation of thermowell. Drift occurs in thermocouple or RTD element due to change in metallic property. This is related to again instruments. Drift for the measuring device can be systematic or random due to wear and tear. So then again they have quoted orifice example, and the examples: zero drift, span drift, zonal drift. So zero drift means the changes in input to output. Span, it will take a more time to get the outcome, and zonal, in between the process the problem is stuck, outcome is not yet occur. So this will be the things you can just write and draw the things. झालं की सांगा मला. झालं का रे? पॉइंट्स वाइज व्यवस्थित लिहा. While writing the things, it is just like a notes. No need to read again another books and all that. Likewise, you will have to write. And of course, in assignment also, we are going to cover these things. Or Aniket, Sampath.
Yes, sir.
Yes, sir.
Okay. So now next point is about zero drift, span drift, and zonal drift. I have quoted here the write-up. So I'll read. The zero drift is defined as the deviation in the measured variable starts right from the zero to output. Span is nothing but it will create a length particular project that will be the span, and zonal means it will be the in the process. So as we have written the thing, the diagram also we have drawn. So you can write this in your own words: zero drift, span drift, and zonal drift. Okay, so this is about the drift. Now next is threshold. This is also one of the static characteristics. Threshold means at minimum value where no output change will occur, or the minimum value which can be defined by the particular instrument or that particular uh, parameter, that we called as a threshold instrument. So that will be the last value, minimum value, zero value. So that we called as a threshold, and this is also important because many times what happen, you can take an example of surface plate, and while measuring the things in quality department or quality point of view, while finding the dimensions from the surface plate, it is very important to set the base or set the zero. And if we not set the zero properly, if there is some changes in micron also, there will be the chances of the variation in the reading as compared to the previous reading. So there should be the threshold. So that will have to take care by proper handling or proper considering the instrument requirement. Correct. So here they have mentioned the definition. The threshold is nothing but the instrument input is increased very gradually from zero. There will be some minimum value below which no output change can be detected. This minimum value defines the threshold of the particular instrument. So just write down the threshold, because if this error we neglect, this directly affect on a outcome. That's why minimum value, proper base or range will have to define. So write down the threshold is, in case of the instrument input, in case of instrument input, which can increase gradually, which can increase gradually from zero, from zero, there will be some minimum value below which no output change can be detected. No output change can be detected. This minimum value, म्हणून आपण least count घेतो बघा, vernier caliper if we can use, so it has having proper least count. This minimum value defines threshold of the instrument. Threshold of the instrument. Now, next is static characteristic. Sensitivity. Sensitivity. So any one of you can tell me the example of sensitivity related to instrument, related to instrument. Tell me what is sensitivity. Of course, it can be changed with respect to output and input. That will be the sensitivity. So can anybody? Because all might, I think most of you are doing job. So just tell me. Yogesh?
Instrument like even though what you can say. Hello.
Can you repeat? Can you repeat?
You can means even though small example is digital vernier.
Correct. Digital vernier caliper. That is an example. If list counts is wrong or if we have set wrongly, there will be the reading difference. So that will be the comes under sensitivity or any flow measurement. In that case also, we'll have to consider flow through the nozzle is different and flow through the open pipe is different. So there is also the chances of the measurement or flow measurement is in case of various types as like laminar, linear flow, turbulent. So that will be occur. So that depends on the situation. So that will be the sensitive. Or else we can see many times the instrument is sensitive, means it will directly given the reading suddenly, or else it will directly give the output suddenly. So that will be the sensitive. Okay, many times what happened, the instrument is suppose if it is having error, so it can run fastly or it can be run slowly. It will not give the proper reading. So that will be because of the handling and all that. So that's why the sensitive or instrument will have to handle carefully for the and the worker or the operator who is going to handle that thing, that are he or she has given the proper training, and then he will get the proper output. So that's why we'll have to consider the sensitivity. Just write down the next point related to sensitivity. Sensitivity is the change of the output with respect to input. Change of output with respect to input. Okay. Now, next point for the static characteristic, bias. Bias. So bias is nothing but, I think in MQC you have learned this word, bias. Can anybody tell me what is bias? What is bias effect? Prashant, are you there? Okay. Aniket, can you tell me? Hitesh? Hmm. Okay, Yogesh, you can tell.
Yes, in my case, I will to quote an example of control wall. When we say a CV of 50 for a 2-inch valve, this is a true value. While taking a few readings, it can be varies from a plus minus of 10%. Then we can say control wall behaving like a bias.
Yes. Correct. Good. So see here, for your kind information, all the Yogesh is working on a instrument innovation product, and he is developing the product, new product, innovative product, and he is also basically designer. Analysis मध्ये तो काम करतोय. तो तुम्हाला पण माहित असलं पाहिजे. म्हणून मागच्या वेळी तो काही जॉईन होऊ शकला नाही. So whichever be the parameters or whichever be the important things related to industrial background, so you can ask him also. Correct. So this is a bias. Bias case means some ambiguity, some confusion will occur at the time of the taking the things or taking the reading. So that will be the bias. So write down from your end. Bias is nothing but difference between true value, true value, and average of observed value. So reading average, average of observed value. So this come under static error. Next will be the repeatability or reproducibility. Repeatability or reproducibility. Can anybody explain me this? Repeatability or firstly explain reproducibility in the instrument means what? Definition in front of you. So I'm expecting answer from your side. See, the session will be interactive. फक्त मीच बोलत चाललोय, मी एक्झाम्पल सांगतो. इन्स्टेड ऑफ दॅट तुमचं पार्टिसिपेशन असावं असं मला वाटतंय. Can anybody tell me what is reproducibility with application or with example? Because name itself indicate what is that reproducibility. Anyone? Aniket, Mahesh, Sagar.
Sir,
Yes, Mahesh, you can speak.
is the degree of stability
Degree of stability we
when the
cannot say. Do you have any example?
some
Okay, no problem. Anyone? Sagar, Sampath.
Sir, if we take example of petrol pump, so every time when we request for 1 liter petrol, it dispensing only 1 liter petrol at any season, like in summer, winter, or the correct.
Correct. Very good. Good example. So reproducibility, it indicates that the whatever be the readings are there, that reading is same for every. But in practical, it is not possible. As we know, in space, uh, there is no gravity, and if we can take the consideration as like gravity effect there, so it's of no use. So reproducibility means the same reading you can get everywhere. Correct. So that will be the instrument fault. So that we called as the reproducibility. And the repeatability means again and again same readings will out or will get the outcome within a span. Whenever you are taking, suppose you are doing a theory of motion experiment for load condition, apply on the shaft and gears. So in that case, the every time reading is same, and that will be the repetitive readings will occur. There is no change as I am applying the load, I am increasing the parameters, so no change will be there, and same answer will be there. Again, this will be the error or fault occur in the system that we call as a repeatability. So this both are harmful for the researcher. So that's why we'll have to avoid this. So just write down this reproducibility and repeatability. तुमच्या पॉइंट्स मध्ये लिहा व्यवस्थित शॉर्ट मध्ये. Okay, if you have seen the timetable, our academic calendar. Very soon we are going to conduct the test and all that. As per the consideration, the upcoming session we'll have to conduct next week. I think we'll take the test, and of course that test will be we'll have to submit hard copy, and the respective subject teacher will give the printouts of the test or soft copy of the test that you have to make a print and then we'll have to submit on next Saturday. Correct? I have mentioned over here in academic calendar 17 to 20 March. I have quoted here the date. So in this week, we'll try, or else because lot many programs are going on related to UG. UG unit tests are going. So that's why I've changed the plan as per the timetable. In next weeks, we'll conduct the session or we'll conduct the unit test. So you'll get the unit test on daily basis, like research methodology on Wednesday. Thursday you will get MSMB. Fourth, then Friday you will get CAD and so on. Both the we have divided. I'll circulate the timetable also, and according to that you will have to solve from your end and submit it on Saturday. Likewise. Okay, so this is about the reproducibility and repeatability. Next, tolerance. So this is also important. So while doing the machining or while developing the product manufacturing, we'll have to consider these terms because there are the tolerance is the effect which will help to define the product, because many times what happened at the time of assembling, the two parts manufacturers are different. In that case, the tolerance is the only device or only parameter which helps to join that part or make the assembly very simply or very easily. We can assemble the things because of this tolerance. So it can we can say the maximum allowable error in the measurement is specified in terms of some value that we called as a tolerance. And this kind of the tolerance we can learn or we can find from the design data book. Suppose if the shaft is having 50 diameter, for that if I applied the tolerance, so I will have to consider the upper and lower limit for the case, and that upper and lower limit again depends on the structure and material condition. So for that we have used many times the design data book for the tolerance case. And basic need is that so proper engagement or proper assembly can be done if the two manufacturers are different, no problem. So there will be the assembly. That's why you can see the Tata Motors plant is here in Pune, and some parts are manufactured in Gujarat also. So that can be combined and then prepare the car and all that because of this tolerance. So we are aware about this term mostly. So can anybody tell me any example other than this related to tolerance? टोलरन्स बद्दल कोण काही सांगू शकेल का? प्रणव.
Yes, sir.
Can you tell me?
Yes, sir. We can take an example of our pen. Yes. If I using classmate my pen gel pen having the nib, and another pen if I take another pen, then आपण सुद्धा दुसरा जरी पेन असा घेतला त्याची आपण निब सुद्धा बदलू शकतो. Yes, the kind of tolerance कारण interchangeability मेंटेन होते सर टॉलरन्स मुळे.
Correct. Interchangeability is term which is very important. Interchangeability means applicable to everywhere. It is not like that while manufacturing the suppose nut and bolt. So suppose my one component nut is not available. So in that case, I will have to not go to the directly market to purchase that single nut. I will have to go inventory shop of my company, and through which I got the nut, and for that particular bolt is available. So it can fit suppose M8, M10, whatever it is, as per the standard. So that's why tolerance are important. Okay, take. So just write down the things. Tolerance. Example. Yogesh, you want to say something?
Tolerance is very vast you are able to hear me, right?
Yes, yes, I'm
Hello.
hearing.
Yeah.
Yes, yes,
Yeah.
Yogesh.
So means just addition to your words means just upper and lower limit, and yes, we need to add a geometric tolerance also. So there will be a concentration tolerance. So that also affect more on the part.
Correct.
And
Yes.
the least material condition, maximum material condition, these two type of tolerance are very important, which will able to low down the cost of the product, machine cost. This
Correct.
tolerance will give liberty to the operator to machine the component.
Yes. Good one. So this is about and very important. According to the condition, we have to define. It is not like that. I understand that this term we cannot write in single word or as like a slide, but it's having a main effect on the outcome also.
Yeah.
Okay. Yes. Good. So write down this tolerance. Next will be the static parameter is range or span. Very simple. So you can tell me the example, range or span. Range or span. The definition they have mentioned the minimum and maximum value of quantity for which an instrument is designed to measure is called as a range or span. I think many times I have quoted the example related to range and span. Can anybody tell me?
Sir, the example of weighing machine, so it have some limit to measure the maximum weight. So
Maximum
when
weight.
we visit any weighing machine, so on
Hmm.
top of that, it is written it's only up to 50 kg or only up to, let's say,
Correct.
1,000 or 1
Correct.
ton, like that
Exactly.
is written.
Yes. Good sample. This is about the range. Or many examples are there related to this. Or else you can see while using bike, suppose Splendor is there. So there is a range. What range? As per the height condition you can use. Correct. So of course, in case of the load condition, as he said about the range, we'll have to maintain the proper span. As we know, the bicycle range, bicycle up to 3 to 5 years is different. 5 to 10 years for that student, range is different or height is different and the structure is different. For case of the racer bicycle rider, their condition and structures are also different. So that will be the range. So according to the requirement, according to the social requirement or society based, it that range can be defined by the designer, and then it can be the launch in the market. Correct? Samja, 4 person or 2 person can sit very easily, and they are interested in four-wheelers. So nano car is the that will be the range for them. Correct? So this is the range as per the requirement or suitability of the societal point of view. We'll have to design by the designer. For that, we'll have to use a proper range. Correct? Many times in hospital, the height meter is also there. The height measure करायची पट्टी लावलेली असते बघा. So as per the age, तुम्ही तिथं सांगू शकता की बाबा एवढ्या रेंज मध्ये हाईट पाहिजे. करेक्ट. आणि एक रेंज आपण क्रॉस केली सपोज आफ्टर 30 or after 25, what is the range? So whatever be your height, so weight to height ratio again it can be, that will be the range. Suppose your height is 165 mm, so your weight should be 65, correct, kg. So likewise things are there as per the range. So you can write by your own word about the range. So these are the static characteristics which we have seen. Correct? Remember, while writing the answer in exam, don't write all the things. समजा static characteristics किंवा त्यांनी विचारले की write down the static and dynamic characteristics of the instrument. Suppose this is the question. Explain or write a note on measurement system. So we know it is a static and dynamic, and question is for 8 marks. So don't write all the things, accuracy, precision. So you will have to write this thing and explain 2 or 3 parameters out of this. Understood? Or else what happened? For that 8 marks, we'll have to spend half an hour unnecessarily. So it's of no use. So ते पण कळायला पाहिजे तुम्हाला. मेजरमेंट सिस्टीम जर विचारलं असेल, स्टॅटिक मधले 2 एक्सप्लेन करायचे, डायनेमिक मधले 2 एक्सप्लेन करायचे. So likewise you will have to follow as per the question demands. Demands म्हणजे काय? मार्क बेसिसवर. त्या पद्धतीनेच आपण पुढे जायचं. Okay, so these are again desirable and undesirable parameter. Undesirable means not sure, sudden. So that will be the parameter. Drift is there, dead zone is there, many dynamic errors are there, hysteresis is there. Desirable means we can control it, we can finalize it. So that will be the accuracy, precision, sensitivity, reproducibility, resolution. Resolution means the ability which can be shown nearer value, that will be the resolution, and static error. So you can just put this graph in your answer also. So static characteristics. So write down 2 things: desirable and undesirable. Desirable and undesirable. Okay, so this will be the additional parameter you can put in your answer. Next, I have explained the things: accuracy, precision, and all that. So we have already studied this. This is for your this is just an study material for you. Correct? Precision means what, sensitivity what, output, input, reproducibility, resolution, and all that. Then we'll move toward the dynamic characteristics. We have covered the static characteristics. Next, write down dynamic characteristics. Dynamic characteristics. So we have seen the static characteristics. It can be slowly changed with respect to time. Correct? Slowly change with respect to time, as like sensitivity. We have seen drift. We have seen. Correct? So it can be slowly changed with respect to time. But dynamic characteristics means it can be suddenly or rapidly changed with respect to time. That we called as a dynamic characteristic. So in that we are going to see the various parameters in dynamic characteristics. Suppose speed, any speed of the component, it can be sudden change. Correct? So that will be the dynamic characteristic, because with respect to time it is changing. Then again we can put the example of fidelity. Fidelity means whatever be the readings given by the instrument that are same after particular interval of time, and if the fidelity is not proper, then there will be the chances of the dynamic error occur. Correct? So the changes of the reading particularly with respect to time is called as a dynamic characteristic. So just write down, it is a set of criteria. It is the set of criteria for the instruments which are changes rapidly with respect to time, called as dynamic characteristic. Here, dynamic error. We have seen static error. Static error means what? True error minus calculated error or observed error. Here also dynamic error is same, but here the changes will occur with respect to time, and that changes is rapid. But in case of the static, we have seen slow changes. Therefore, definition is same, but The outcome is different. That's why true value and measured value, which can be rapidly changed with respect to time, that we called as a dynamic error. So you can write dynamic error. Dynamic error. Difference between true value and measured value. For that you can write rapidly changing in case of true as well as measured value. True and measured value. Okay, have you done this? Okay. So this is again a chart, desirable and undesirable. So we are going to learn about speed of response, fidelity, which are desirable, which are predictable, but undesirable in case of that dynamic error, as we have seen, suddenly change input with respect to, and then outcome is suddenly change rapidly. So that will be the comes under dynamic error. Then lag, we are going to see lag is nothing but it is the difference. So that is again uncertain, that also we have seen. So just write down this dynamic characteristic in case of desirable and undesirable effect. Speed of response, fidelity for desirable, and for undesirable we'll have to add dynamic error with respect to lag also. Then we'll see speed of response first. In case of the speed of response is nothing but it will change the reading suddenly from initial to final. That will be called as a speed of response. As per our basic idea of dynamic characteristics is the rapidly changes with respect to time. So whatever the reading here, speed is the reading which can be changes with respect to time suddenly from initial to final position. That will be the rapid or speed of response. That's why example you can if you are using two-wheeler, so every time there is a necessity for changing of the speed, and that speed response will very easily occur, rapidly occur. So many times suppose road we are riding on a highway, in that case I suddenly I can go directly on last gear, and it can be the system can work smoothly. Suddenly the speed breaker will be there, speed of response is changed, correct? So suddenly from 4 to second gear I will have to shift for the slowing for making speed of the bike slow. So that's why that speed of response is important parameter in case of the dynamic analysis or dynamic characteristic. So this is just about the speed of response. And then fidelity. Fidelity is nothing but which helps to find out the instrument which does not have any dynamic error, correct? Means the rapidly changing will not be occur. So in word definition you can see the fidelity is nothing but the degree of which the measurement system can indicate the changes in the measured quantity without any dynamic error, without any rapid error which can be with respect to time. So that will be the called as a fidelity, correct? In case of the fidelity I have quoted one more things is there. So again, the system is faithful, that is called as a fidelity, which can be respond every time correctly, that will be the fidelity, correct? So this is about the fidelity, and this comes under dynamic error, desirable property. So just write down speed of response. Speed of response, it is defined as it is defined as the rapidity in a measurement system, a rapidity in a measurement system responds to changes in measured quantity, to changes in measured quantity, measured quantity. Okay, example, you can put any example. Can anybody give me the example? Speed of response. Because it comes under dynamic characteristic. Changes rapidly with respect to time. Tell me. Yogesh?
Hello.
Paul.
Can take an example of Chandrayaan.
How? Tell us.
Speed versus time.
Okay, effect.
Yeah,
Yes, yes.
With respect to time, it goes on increases speed
Correct.
or decreases at some extent.
Correct. That is comes under this speed of response, of course. And of course, when satellite is goes in the space, there will be the response parameters are also there. So as per that we'll get the proper graphs, some ideas, some knowledge. So that is again depends on that speed also.
Yes, yes.
Okay, no problem. Good.
Even though in the flow meters, flow meters, some flow meters like they also take a reading of velocity of fluid, and accordingly it shows. Means there are some calculations, but the velocity of fluid means speed is there, and it converted and it shows in the flow meters.
Correct.
The magnetic flow meters are there.
Yes, according to that speed can change.
Yes.
Okay, good. So write down this, then you can write the fidelity. Let's write down the definition. Fidelity. So you can write this definition also. Same. Fidelity, it is nothing but the degree to which an instrument indicate the changes in the measured variable, without dynamic error. This is very important. Without dynamic error. Of course, in bracket I have mentioned that is the indication of belief on the instrument. Indication of how much faithful system respond. How much faithful system respond to the changes in input. Okay. So can anybody give me the example of fidelity? General example are also valid. No issue.
speedometer of two-wheeler, while starting it shows to and fro motion, so that we
Correct.
can say that it is actually fidelity.
Ekdam barobar. Good one. Anyone? Any other examples related to fidelity? Bhushan? Mahesh? Tell me. Pranav? Amol has given very clear example related to the fidelity. So now I am expecting from your end. Because this is an important parameter. If it is not, then system get fails or readings get wrong directly. So the researcher many times confused at this point. The fidelity. Anyone?
Sir, any
Yes, sir.
error-free system, if we say, for example, sensors, actuators that we are using on machinery, for example, thermal sensors we are using for analyzing any system to check the temperatures, means what temperatures at what area of the system that we are getting. So the belief that we are getting same input and output without any error with reliability. That can be the example of fidelity.
Correct, correct. And that readings are every time. Means anytime I can take. Suppose at 9 a.m. Suppose I am taking reading and same reading 5 p.m. also will get. That we called as a fidelity. That will be the faithfulness. That will be the belief on that particular machine through which we'll have to find out. That is called as a fidelity. Correct. So this is very important. Why this is very important? See, this is about the instrument we are talking. And if the instrument is not properly maintain the fidelity, then the most of time error will occur many times. Many times. Suppose in case of wind blade, I told you the blades are used, and suppose blades are manufactured 4 5 year backs, and at the time of manufacturing they have given the reading of RPM, suppose 100 RPM. In that case, after 4 5 years, it is there might be chances that 100 RPM is reduced to 50 RPM. So likewise things are there. So that's why fidelity is important to get the proper outcome regularly. So in that case, you can see the example, general example also. In case of the cricket, the bats can be used by the cricketer. So they are not using same bat every time, every time. So lot many years, not possible. They have to make the changes as per the requirement. So that's why they have maintained their fidelity for that particular cricket bat. If suppose if someone believe that I got I made the century from this bat, so I will have to use this bat for whole life. Not possible. So that is the magic of that fidelity in case of the instrumentation part. So this is about the fidelity. You can just write down the definition in your own word and quote one example, because many times the proper fidelity question will be asked. Favorite question of university. Fidelity. Just write down the. And those who have not visited college, अमोल विसावे असेल, प्रणव आहे, ही लोक तुम्ही शनिवारी येत चला बरं का. Every Saturday at least you will have to attend the session, meet the respective teacher, subject teacher, meet me, so that rapport get clear. That is very important. Many of the students I don't know who are they. I have not seen them. तसं काय होऊ नये, तुम्ही भेटत चला. Okay, so this is about the fidelity. I think you have written the things. Next one with the lag. Lag. आता हे आपली मेकॅनिकल जनरल टर्म आहे. कोण सांगू शकेल का? Lag means what?
Lag म्हणजे delay.
Yes,
When we are saying that we are lagging behind, it means we are having that much delay, we are behind of that thing.
correct. Example?
Um, for example, actually, when we are doing projects, so we are giving estimation. So
Hmm.
in that term, I'm saying, not in measurement point of view.
Okay,
So
okay.
so when we are giving estimation that in these many hours, yeah, at this date, we will deliver this project. So as per that estimation, we have to implement the project work. So when we are giving updates to our managers, then we are if we are lagging in our work as per the estimation, then we are saying that we are lagging of the estimation, so we may have delay to deliver the project.
Correct. So this will be the general example. Can anybody quote measurement, instrumental point of view example related to lag? Because
Uh,
lags are having, yes,
Yes, sir. For example, we can't measure in seconds, but in microseconds. Suppose because some vernier calipers that I used in laboratory of immersion, so there were few vernier calipers who were somewhat older. So whenever we were taking readings, so it was taking some time to show that reading to display on the
correct,
to display that reading. So that is the lagging time to give the response to our measurement.
correct. Good one. So this is called as actually lag, and I have quoted here definition also. So there are two types in case of lag. One is retardation lag, and second one is there a time delay lag. So whichever the example told by the Prashant, that will be related to time delay lag. So retardation lag means the response of the measurement begins immediately after the change in measured quantity has occurred. So that will be the retardation lag. Can anybody tell me the retardation lag example? Because suddenly change, immediately change. Retardation lag.
Yes, sir. I have one example.
Tell.
Actually, in washing machine,
Hmm.
because right now I'm using it on weekends. So whenever we are, yeah, so that is the practical example. That's why I'm giving.
Okay.
So it's completely automatic. So whenever till the time it sends the water level and the weight of the complete system, clothes and water and all the things. So
Hmm.
till that it doesn't respond. But
Correct.
the time the sensor actuates that level, it gains that level. At that time, suddenly it starts working that system. So that we can
Correct.
see there is a sudden change yeah, in the sensation of the sensor. That sensor is actuating that weight value, and it's getting actuated.
Yes. Yes. Good example. So this is about the retardation lag. So just write down the definition of both retardation lag and time lag. It is mentioned on screen. I think they have mentioned the RTD एक्झाम थर्मोकपलचे एक एक्झाम्पल त्यांनी दिले तेही लिहू शकता किंवा तुम्हाला मी हे पाठवतोय फक्त रिटार्डेशन लॅग आणि टाइम लॅगचं तुम्ही डेफिनेशन आणि एक्झाम्पल कोट करा तुमच्या So these are the dynamic characteristics which we have seen: speed of response, fidelity, lag, and dynamic errors. So these are called as the dynamic characteristics. So while writing the answer, you will have to read question properly and then decide what to write. Correct? As we know all the things, it's fine, it's good. But as per the requirement, as per the time availability, we'll have to write the answer always. Clear? So this is the second beat of fourth unit we have just completed, that is the static and dynamic characteristics of the instruments, and it is totally related with the instrument we are learning as a researcher. Now next point is data collection by digital computer. Correct, that will be the beat. So as a researcher point of view, we'll have to focus how to collect the data. So can anybody tell me, you are doing or you are working on some project, so what is the input, what are the input you have to define for your site as a data, and how you can collect that data? Can anybody tell me what is data collection and how you can collect the data? What are the types of data, or uh, we can say raw data and all that? So can anybody explain me?
Sir, I can
Data
give one
collection.
example.
Hmm.
Yes, I can give one example. Suppose while doing project, so right now one project is going on EM12 push-pull connector, or which is of Belden. So there are so many competitors like Yamaichi from Germany. Then Harting is there, Phoenix is there. So many, even Siemens and all. So many competitors are there. So nobody is
Okay.
having right now the actual product into the market. So Phoenix
Hmm.
is having estimate that on next month they are going to have that product. So
Hmm.
we are also working that on that product, so that at least not first but the second one we will be into the market to introduce that technology in our
Okay.
connector. So
Hmm.
while doing while having research or while starting that work, what the process that we followed is, firstly we have studied the competitors. We
Hmm.
have studied the competitors which are working on M12 push pull connector and which standards they are following. So
Okay.
and the main thing is the data that we are getting from internet. This site should be authentic. It should be either
Correct.
company site or means so for example on Google, so many people, even on Quora, so
Hmm.
many people are giving answers. So we are not that is not authentic site, because they are not authentic person to believe on.
Correct.
So
Yes. Yes.
we are directly visiting those sites of the competitor like Phoenix, Yamaichi, Harting. That is first thing. Authentic sites we are looking for. Then we are checking out, are they having products into the market? If not, then on which stage they are, and what
Hmm.
technology, how much we can study about them. So we collected that data. What is their estimation price? Either they are looking for shielded connector or unshielded.
Okay.
They
Input.
are having only push pull connector, or they are having some rotation and all those kind of things. So this kind of study we are doing, and then after that we are checking that what how much is our construction of our current connector which is having M12 thread, and how we can remove that thread, and instead of that we can use that push pull technology. So, with respect to competitor, we are studying, that is benchmarking. Then we are checking that for push pull, either it should be in plastic snap or metallic snap. So this kind of
Okay.
process that we are following. For example, for
Okay.
snap, we have to decide the material. Then for
Hmm.
that, what is our working condition? Then which are the materials which will be which can be used in that working condition at that temperature value, what forces that we will require. So comparison of materials we are doing. So this kind of process we are following.
Correct. Very correct. So it means that while collecting the data, suppose I want to launch new product. In that case, I will have to maintain, or I will have to do the R&D on that particular project. I will have to do the proper procedure, which can be followed by someone somewhere in previous development, that we need to take, and then we'll have to proceed for further development. So while making the development, the data collection is very important. So basically the two things are there for collection of the data. First thing is data, either it may be qualitative or quantitative, that will have to define. Qualitative means it will give that will be the descriptive, they are having some standards that we call as a qualitative data. And quantitative means it will just give the numerical values as per the quantity. You will suppose you want to launch a product, so you will have to define in previously in what market how much product is sell by the particular company. So that numbers, that is in numbers, that we called as a quantitative data. So these two things are very important: qualitative data and quantitative. Qualitative, as you said, the authentic sites should follow, then we'll have to take an input, or else local sites will not follow. It's of no use rather, and the accurate result देतील हे सांगता येत नाही. Correct. So that will be the qualitative data, and in case of the quantitative, that will be the numerical base. Correct, mass quantity point of view. So this will be the two things which are very important. And after that, the important one is primary data and secondary data. So primary data means raw data, where it available, and raw data related to the particular product. So raw data is very important. Suppose I am doing something product development, and the raw data is available from France. So if it is not feasible to me for that particular product, I will have to purchase the things from France. That material is come here after 4 5 days or 10 days, and then I'll proceed, and again it will require more cost. So if it is so, then I will have to avoid that idea. So that will be called as a, generally we'll have to say, raw data. Availability of raw data is very important. Suppose MIDC is there. In case of MIDC, why MIDC name indicate? Because it is the availability, or government can maintain the availability of light, water, correct, electricity. So these are the important things. Traveling. So likewise, that data will be called as a raw data. And then furnished data means secondary data, on which work has been done. We have furnished the things, so that will be called as a secondary data. So likewise, I told you the four things. First is qualitative data, quantitative data, primary data, secondary data. One by one we'll see. So before that, just write down the definition which mentioned on the slide. So data collection, just write down. बोला की. तुमच्याकडे जमा करा, त्याच्यावर रिसिव्ड म्हणून. हे फायनल आहे का? मला काटे सरांनी दिले, मी काय द्यायचे? कुठले काटे सर? ऑफिस मधले. बर, म्हणजे हे फायनल. ह्याची सॉफ्ट कॉपी मिळेल का आम्हाला? तुम्हाला नाही नाही, सॉफ्ट कॉपी. हो, त्यांचा ठीक आहे, मी त्यांना कॉल करतो. द्या इकडे. दोन्हीचं पण मला द्या, कॅड आणि एकवीस आणि 11, बरोबर. आणि डिझाईनचे. ओके. झालं का रे लिहून बाळानं?
Yes, sir.
So data, now data collection, this will be the definition we have seen. So qualitative, the tools are there, as I told you. Qualitative, just write down this qualitative. अजून कुठे आहे का साईन? Chalo, thank you. Okay, in case of qualitative data, as I told you, that is non-numerical base. So it is related to quality. So they have mentioned, this means that the data collected are in the form of words or sentences. So it is descriptive generally. So that data capture the thing like the nature. Correct. So they have mentioned the feeling and emotions. These kind of the words should not be used in our answer. The data collection methods play an important role in impact evaluation by providing information useful to understand the process behind the observed result. So process done. On the basis of that, we'll have to maintain the quality. As Prashant said, we have to maintain the R&D. So that will be the observed result, we can say. Okay, and the whatever the changes we have to do on the basis of that only. So that we called as a qualitative data. Next one you can write the quantitative data. Quantitative data. Okay, you will get roll number. मी आपलं लेक्चर झालं की मी तुम्हाला हे डिटेल्स पाठवतो. तुमचे फायनल रोल नंबर फायनल झालेले आहेत आणि ते रोल नंबर तुमचे या एक्झामला असणार आहेत फायनल. तर तेच मी तुम्हाला फोटो काढून आफ्टर completion of this I'll send you. So quantitative, that is numerical based, correct? So here in case of the quantitative you can write as I told you, the production quantity ordinary scale, that will be the nominal scale. In case of the interview panel, number of students, vacancies are 2, number of interviews or the applications are 100. So that will be again the quantitative data. Then tools, the way, the method or source used to approach the data in research process is the tool of research. So data is this kind of the qualitative and quantitative. जसं मी सांगितलं, एक एक्झाम्पल क्वालिटेटिव्हचं लिहायचं, एक क्वांटिटेटिव्हचं लिहायचं तुमच्या शब्दात ओन वर्ड, करेक्ट. So this is about the two things related to quality and quantity, which is the important part as per the defined research work. Then we'll move toward the basic, that is primary data and secondary data. As I told you, primary means furnished, not furnished, raw data. So that will be the primary data. And secondary means we'll have to do something, that will be the secondary data. So just write down below that the collection of data divided into two parameters. Collection of data divided into two parameters. First one be the primary and second one be the secondary data. This will be the classification. So as I told you, the primary is initial data, raw data. Correct? See, the primary data refers to data collected by the researcher for the very first time, raw data, very first time, from the different sources with particular problem or particular research gap. Correct? So this will be called as a primary data. Write down definition this. This will be called as a primary data. लिहून झालं की सांगा बाळांनो. After completion of write-up, you just tell me so that आपल्याला पुढे जाता येईल step by step. Primary data. झालं का हे? Have you completed this?
Yes, sir.
Okay. So now what are the primary data? See, this picture shows everything. Primary data on the basis of research, survey, market survey. And according to the market survey, we'll have to fulfill the requirement which not satisfied by the customer. Correct? So that will be our aim, the problem definition, that is survey. Correct? So this will be the first step or first primary data. Initial stage hai, that's why it comes under primary. Then questionnaire. This is again primary data. The questionnaire is again many of types. I mentioned in the slide. Suppose the questionnaire is based on the report or feedback. That questionnaires are different. If the questionnaire based on the particular person, that questionnaire is different. Example मी तुम्हाला सांगतो. Suppose if you watch any movie, and after completion of movie they are asking you the question, how was the picture and all that, what are the characters and all that. So that questionnaire is different, correct? Suppose any celebrity come to for the opening of any uh, uh, function. In that case the questionnaire is different, correct? The questionnaire is like this: why you are came here, or what why you are what is your interest in this. So that kind of the questionnaire. Second thing, if you are going to visit a mall, there is again the person can come and giving you the questions. So this mall is about how you feel, what are the things, what are the necessity, is any drawback. So that will be the questionnaire. Again, the questionnaire in case of the parent meet, the parents questionnaire are different. So we are quoted, or we are doing the questionnaire like this: uh, have you got your answer, your ward is doing this, we are doing this kind of the things, what is your opinion, we are developing the things, we are placing the student, what is your opinion. So this kind of the questionnaire is different. So it means that the questionnaire can create, that is the raw data, इनिशियल डेटा. काय काय क्वेश्चनर असे असतात की डिस्क्लोज केले जाते. समजा जसं म्हणला प्रशांत, R&D मध्ये जर मला महिंद्राची कार तयार करायची आहे आणि मी R&D डिपार्टमेंट मध्ये आहे, तर आय विल हॅव टू टेक R&D ऑफ टाटा, बजाज, ऑल द कार्स, and then we'll have to discuss among the group, that is R&D group, prepare a question आहे, आणि त्या फक्त आपल्यात राहणार, ग्रुप मध्ये राहील, त्या बाहेर येत नाही, और त्या पब्लिश होत नसतात. So that will be the kind of the questionnaire is different. So this is about the questionnaire. Primary raw data, त्याच्यातून आपण final outcome काढतो. Now experiment. So many more. This will be the experiment, prior experiment. Either it will work or not. That we called as again primary data. Then direct interview, as I told, it comes under questionnaire. Then observation. Initially we have observed the things. Suppose आज मी एखादा प्रोजेक्ट बघितला, मला वाटतं की मी करू शकतो, तर त्या पद्धतीने वर्कआउट करून नवीन त्याच्यात ऍड करून मी केलं. दॅट विल बी द ऑब्झर्वेशन पॉइंट, correct? Now the telephonic interview, many times the suppose it is not possible to go there offline. So in that case the telephonic things are there. This will be the primary data. आपलं जे काही लेक्चर चालतं, this is the primary data. हे काही आधी लेक्चर झाले आणि त्याच्यात पब्लिश करून मी काम करतोय असं पण नाही. That will be the telephonic किंवा primary data. I hope you understood this primary data. Is it?
Yes, sir.
Okay, write down this or draw the block diagram. Primary data, under that you have maintained the sub parts. And every time while writing the answer, you quote an example always. And in your own words, that is very important. कारण उद्या असं व्हायला नको की चेक करताना त्याला असं कळतंय की सलग मी 11-21 पेपर झीलचे चेक करतोय, तर त्या केसमध्ये त्या एक्झामिनरला वाटायला नाही पाहिजे पूर्ण पाठ करून आलं, सेम एक्झाम्पल सगळेच देतात. नो. So whichever be the example, you will have to select from your intellect. तुमच्या पद्धतीने ते जाऊ. Okay, is that clear?
Yes, sir.
Okay, today we have seen only 2 points. First one is a characteristics. We have seen the static and dynamic. In static we have seen these points, and in case of the dynamics we have seen these points: speed of response, fidelity, dynamic error, lag. And with example, after that we have seen the data collection, which is very simple: how to collect the data, qualitative and quantitative. And then primary and secondary, I told you the primary means what. In coming session or next lecture, I will tell you the secondary data, what are the inputs, what are the requirement of that, and so on. ठीक आहे, इथपर्यंत सगळं आजचं झालेलं समजलं का तुम्हाला?
Yes, sir.
Sir.
Okay, चाल. Shall we stop here?
Okay.
Yes, sir. I'm good.
क्वेश्चन पेपरचं जसं मी तुम्हाला बोललो, फॅकल्टी मेंबर्स हे तुम्हाला क्वेश्चन पेपर तयार करून ठेवतील. शक्य झाले तरी माझा क्वेश्चन पेपर आजच मी तयार करून पाठवेल. तो शक्य झालं तर शनिवारी तुम्ही सबमिट करा, ते बेटर राहील. बाकीच्या फॅकल्टीची मी मीटिंग घेतोय आणि त्या पद्धतीने पुढची प्रोसिजर करतोय. पण लवकरात लवकर क्वेश्चन पेपर मिळेल याची तुम्हाला मी